What that illustrated, though, is the general issue that signal handlers are concurrent. Here's another problem, another program, which it turns out will have some issues. I'm using volatile, so that's not the issue. I have two variables that are going to be shared between the signal handler and the main program. One of them is a child running flag that I'm using the same as before. This loop goes around, and whenever a child's not running, it creates a new one. But also, I've decided to use wait PID with the PID that I really should be waiting for. Right? There's only one child running at a time. I can remember PID from fork and use that in the wait PID. This shouldn't do anything different, actually, but let's try it out. So let's still call this repeat.c with the new code. I'm going to compile it with optimization, and it should be fine because I am using the right flag. And you see the program got an error. It got an error right away. Wait PID error, no child. That means that this PID was somehow not right. To better see what's going on, let's try a little bit more. I'm going to do SIO put L to write a word. To write a long, which I will use as write the PID that we're going to wait for. And then also write a new line after that, so that each process ID that we're about to wait for is printed. It turns out this will show us a little bit about what's going on. So we try running again. Let's see. I got the I and the O reversed here. Okay, what you see is the program was going along happily for a while, but then it waited for 4882, and it waited for 4882 again. How can that be? Let's try it one more time. This time you see it went a lot longer, but eventually ran into the same sort of problem. The numbers were going up as we expected until it was repeated. Well, the issue here is that our program installs a signal handler, then it forks, then this process ID assignment, that has to happen after fork returns, right? But the child process is created by fork itself, so meanwhile, that child process could return right away. There's no constraint on this dot and this dot. They both have to happen after fork, but either one could happen before the other. If PID equals happens first, if this assignment right here happens first, then all is well. The return of the child process sends sigchild back to the main process, and then done happens, which does a wait PID on PID that we set. However, if return actually happens first, which is allowed because these dots are unconstrained relative to each other, then wait PID will happen before we did a process ID assignment. It'll still have its old value. We will be trying to wait on a child that we've already waited on and the process ID has been reaped, so that's where the error comes from. So the problem here is that we didn't really expect a sigchild to happen in the middle of this PID, because textually it looks like it can only happen after. But of course, the textually is a little misleading here. The process graph is more accurate. One solution is to make sure that a sigchild doesn't happen in this region where we didn't expect it. And we can do that by blocking signals in that region. So we can use sigprocmask, as we introduced before, we set up a set that has just sigchild. We block it while we fork, and then unblock it after the fork. And if we use this in place of our main code over here, so new main, then we should see that things run just fine. The numbers keep counting up, they never duplicate, we never get an error from wait PID. It really is concurrent.